hear your question. So.
Thanks everyone for joining this afternoon. Today we're going to be talking about how to activate your Lakehouse with Unity Catalog, and we're going to be getting into all of the neat tips and tricks of using Unity Catalog to maximize the value of your Lakehouse. But to get into all of that, I want to start off with a very simple question, which is what makes a great Lakehouse? And when people kind of see this question, there's a lot of different ways to interpret it. Some people might think it's all about performance, getting really great query performance or cost optimization. But to me, when I'm thinking about a great Lakehouse, I'm visualizing this in my head. This perfect Italian villa on Lake Como. Real estate goals aside, this is still the metaphorical goal I'm working towards to make sure our Lakehouse at Yipit looks something like this. And I think everyone else who is a platform admin is striving towards this goal too. But to put it into words, I would say that a great Lakehouse is an active one. And by that, I mean that your business operations or your organizational goals should all be revolving and be resolved by using the Lakehouse. If it's actively being used, it's clearly creating value for your business and it's doing its job. There's a couple of things that I've noticed from the Lakehouse in terms of characteristics that really point to if it's being active or not. The first thing is you have to have fast time to insights. That feedback loop from a certain data team, from having a question to using the Lakehouse to get an answer and moving forward and making decisions has to be quick. And if it is, you're going to have data-driven decisions being the norm in your organization because there's every incentive to use the Lakehouse to solve problems. The other thing your Lakehouse needs to have is broader integration with the stack across your company. And I don't just mean your data teams, your technical and non-technical teams alike should be connected to the Lakehouse, either directly or indirectly. And if you're doing that, you will be establishing a source of truth within your organization. So no matter where people are working with data, they will be pulling their information from the Lakehouse and having a shared understanding of the data within your company. And the last thing you need for an active Lakehouse is effective data governance. So for all those new opportunities, projects, challenges that arise for your organization, you're able to deploy data assets strategically to be able to resolve that. And that all together will make sure that your Lakehouse is really actively used within your organization. And these are all things that sound great on paper. And the thing that we've learned after using the Lakehouse for several years is it actually takes a lot of work. Just turning on the Lakehouse and pointing it to your data teams is not going to get you all these three things out of the box. It takes effort. And on top of that, as your Lakehouse gets larger, as your organization gets more complex, all of that complexity is going to creep into your Lakehouse and make these three things even harder as an administrator to make sure that happens. And so that's really what we're going to talk about today. It's a story about we at YipitData have grown with the Lakehouse over the last several years. And along the way, we've had many stumbling blocks, a lot of growing pains, but we've seen how Unity Catalog is actually solving those growing pains. And to get into that, you have to understand who we are at YipitData. So at YipitData, we answer key questions for investors and corporations. And what that really means is we're a trusted source of insights using alternative data sets. We analyze every day billions of data points to essentially track KPIs across over 1,000 companies. And our primary customers are investment funds and corporations who every day rely on us to make better business decisions using our insights. And our products really come in the form of a variety of channels. That includes research reports, KPI dashboards, custom data feeds, as well as really granular and consulting style solutions. And what makes our product stand out is our ability to integrate a variety of different data sets into our Lakehouse, give our analytics teams the full functionality to be able to process that data, and give very rich and granular insights to our clients. But how does that really work? Every day we're pushing out these insights to our clients, and the easiest way to think about YipitData is we're really just a big funnel. So we have a variety of data sources coming into our lake. They come from first-party panels that we own, licensed data sets that we work with and procure with data partners, as well as public data sets, for example, internet websites that we're scraping. And we're scraping thousands of websites each day. So we're bringing that into the Lakehouse, and our analyst teams are doing a couple of things to really process that data. Alternative data is messy by design. They don't really answer the questions that our clients are really interested about. So our analysts are spending all of their time every day building out methodologies to map that raw unstructured data to KPIs that are of interest to our clients. And as they're doing that, there's a lot of ETL and data wrangling that has to happen behind the scenes. And ultimately, as they're producing these insights, they're doing a lot of benchmarking and quality control to make sure our clients can really trust the insights that we're publishing. And all of that work is what goes into our products. And while I could talk about our products for a long time, I want to highlight one product just to give you a concrete example of what our clients experience. That's our YipitData Live dashboard, one of our more recent dashboards that we've released to our clients. And essentially, when our clients log into our customer portal, they can access live data experiences like this dashboard that you see here. And the goal is to allow our clients to be able to discover insights about the companies they're interested in as soon as they happen. And so, for example, this dashboard is tracking North American net sales for Amazon. So an investor or someone who operates in the retail space can see every day the retail sales for Amazon. And you can imagine how powerful that is, because in between quarters, they get a live read on how Amazon is doing. And there's a bunch of different KPIs that we're tracking, a lot of dimensions to understand that data. But the cool thing, and why I bring this up, is when they're logging into our customer portal to see this kind of information, it's querying our Lakehouse. They're pulling the latest and freshest data from our Lakehouse to be able to do this analysis at any given time. And this is just one of many dashboards and data experiences that we offer. And so to make this happen, we have to provide a lot of data. We work in our Lakehouse with over 16 petabytes of data. All of that's in the Delta format. We use Amazon as our cloud provider. And to keep this data fresh, there's a lot of ETL that has to happen. So we're running over 2,000 daily pipelines. All of that's orchestrated through Databricks. We use Apache Spark to do the data processing. And ultimately, that's what's being organized through those ETL pipelines, over 210,000 tables. All of that you can think about as a collection of bronze, silver, and gold tables that our data teams independently own. And so we have over 290 kind of analyst-type personas who are responsible for managing these pipelines and producing these tables. And those tables are what ultimately go into our client experiences. And this entire platform that I'm talking about today is kind of managed by 13 data engineers like myself. So how does this really work in practice? The key thing is we provide a self-service data platform so our data team can be operating as efficiently as possible with their data sets. And essentially what happens is we follow a data mesh architecture where different teams focus on different data domains. Some may specialize on our first-party panels or our licensed data sets or particular sectors or client experiences. But the overall goal is the same. Each team is responsible for their own set of bronze, silver, and gold tables. And those before Unity were in Hive Metastore. And essentially, they take those gold tables and share it across other teams. And that's really how data flows from kind of the source data sets that we acquire for our organization to the products that are going to our clients. And so because of that, and because of all the autonomy that we give to our data teams to work with these data sets, we want to give a lot of uniformity in their analytics capabilities. So we have a lot of tooling that we empower these data teams with. So we give them standard libraries to wrap around Spark and make sure that working with Spark and writing that ETL is as simple as possible. They can use Databricks workflows for all of the orchestration, and they have preset cluster options, so they don't have to worry about wrangling Spark configs. And for the data distribution to our clients, we have built our own internal kind of application. We call it Dispatch, but the idea is once we have those gold tables, we can ship it to anywhere, whatever cloud our clients want it, and that really shouldn't have to be a concern for these data teams. As they're doing their work, they're using those interactive notebooks, Databricks SQL visualizations to really understand these trends over time. And importantly, the messy kind of data platform infrastructure, all those gory details, we hide away and we abstract as data engineers so our analyst teams can do what they do best, which is really produce insights for our clients. And so this decentralized platform was key to becoming a trusted source of insights for our clients, but what happened next? The reality is the strategy worked and almost too well because we became an alternative data market leader with more teams, data sets, and product types than we could have imagined. So over a couple of years, our team grew from over 50 analysts several years ago to over 290 today. We went from 4 petabytes of data to over 16. And our products evolved from just research reports, which was historically the only product that we provided, to data feeds and dashboards and custom solutions. And all of this probably sounds great, and we were over the moon about it. But something that we didn't recognize or appreciate along the way is as this evolution happened, there is a lot of complexity that goes into managing a data platform. And we started to hit those lakehouse growing pains I was alluding to. The first problem is we started to realize that data access becomes really complex when you're large. So that kind of 300 body of data analysts is really organized across 50 sub-teams. Each one of these boxes, you can imagine, is one of those teams. And for each of those teams, we started to have to create isolation of code, data, and cloud resources. We kind of went from that lean, small startup to having to be a little bit more mature in our data access. And the problem here is Hive Metastore, which we were using to organize our data, didn't really give us much support in terms of providing this isolation. So we'd have to go into the cloud infrastructure layer and kind of give each team their own cluster, instance profile, bucket policies, IAM policies. And it turned into a real challenge to administer because these teams are not that atomic. They actually do a lot of collaboration with each other. And so onboarding new teams to make sure that they have access to each other's data sets was really challenging. It became a complex infrastructure deployment that started to not really scale. And as we had more and more walls kind of built up, and isolation on its own is not a bad thing. We're doing it for the right reasons, to protect our sensitive data assets, to maintain compliance internally, all of that important stuff. But it was hindering collaboration. And so many of the tables that were being shared across teams stopped being shared because of these barriers that we had to put up. And that really limited the analytical capabilities of certain teams. And as these kind of restrictions continue to build up at the cloud infrastructure layer, it's not really transparent to these data teams because they're almost exclusively working in Databricks. They don't really understand the barriers that are being in place. And so a lot of teams would then duplicate certain data sets, build workarounds for the constraints that we've administered to them, and that led to a lot of tables being forgotten or kind of completely overwritten downstream. And there was a lot of inefficiency there because of that lack of collaboration. Additionally, because these teams were kind of working without kind of clear collaboration and sharing of data, there's a lot of cost overhead that started to accumulate because of those unused or duplicated tables. And so we noticed that our lakehouse was becoming bloated. Hive Metastore, for example, doesn't really give you any opportunities to see table activity on its own. So it's hard to know, even as a platform administrator, where to optimize your cloud storage. And deploying pipeline improvements, so for all of the tables and pipelines that were actively being used, it was still challenging because teams didn't really know from one another how those tables were being used, if they're going to make a change, is it going to break something downstream. It's a massive organization, and there's a lot of data exchanging happening, and so it became very challenging to deploy improvements. And additionally, all of these problems started to bleed into our product and top-line growth. So we had a lot of product opportunities that became blocked. I kind of mentioned and showed the Amazon Live dashboard. That was part of our interactive analytics experience. So that was a new venture for us the last couple of years. And one thing we noticed is that as we were kind of scaling up those experiences, we ran into a lot of performance bottlenecks with Hive Metastore. Those kind of BI experiences, when we're working with tables in a catalog of our size, it just simply can't do the job, and we ran into a lot of problems with that. And for some of our new verticals, for example, our corporate solutions and data partnerships teams, we exchange data with those clients, but we need to work in ultra-sensitive environments because of the data we're receiving from them. And so that kind of data isolation and bespoke delivery requirements required us to build really brittle integrations in our cloud infrastructure because we couldn't isolate the data properly at kind of the catalog level within Hive. And that created a lot of barriers for them to work efficiently. And so ultimately, our lakehouse was very far from Lake Como and started to look like this. And that was the last place we certainly wanted to be as data engineers. And to put it into words, our data governance constraints turned into business challenges. And we had to really think about, from the ground up, an entirely new approach to manage data. And that's really where Unity Catalog came into play for us. And so for those of you that are familiar or hearing around about Unity Catalog at the summit, I really want to just go over some core features of how they're addressing these problems that we have. The first thing that I'd say is stand out about Unity Catalog is the capabilities to organize your data sets. And the key thing there is it gives you a 3-level namespace. It sounds pretty simple, but essentially you have your tables, they can roll up into schemas or databases, and those can now roll up into catalogs. The cool thing about this, it's all fully compatible with Spark SQL APIs, Python APIs, and it just works out of the box in the Databricks environment. But with this 3-level namespace, you get a lot more organizational features. And the important thing there is for any one of those data objects, you can grant granular permissions through ACL statements. And so basically, you can say specific teams and users in Databricks have access to a particular table, schema, or even an entire catalog. And that gives you a lot of capability to really customize your data access to meet the requirements of your organization. The other thing that Unity does that is really important to understand is it gives you a lot of visibility into your lakehouse. So you get to see all of your data objects in the Databricks workspace, in the Data Explorer, as well as searchable in the UI, which is really powerful. And that allows for any user to particularly see exactly what data they have access to. As an administrator, you get some top-down visibility as well. You get audit logs for all of the Unity Catalog activity, so you can see what's being queried, who is doing those actions, and even lineage information to really understand at scale what's going on in your lakehouse. And ultimately, there's all full REST APIs, so essentially you can use Unity Catalog, administer it through SQL, through Python, but also through the REST API to write and kind of automate a lot of functionality. Now, I want to talk a little bit about setting up Unity Catalog, and I'm going to go really quickly through it because I'm pretty sure you can ask ChatGPT, and it's going to do a better job than I am. But the key headlines are, you need to set up Unity Catalog in your Databricks account. And the important thing there is you need to make sure your user groups in Databricks are organized at the account level. So essentially, all of your users and groups in the Databricks account is what's going to be allowed to be given access to your data objects. So you need to make sure that's all there. If you're an older Databricks customer, that might be a little bit of work. The other thing is you need to create a Unity Catalog metastore. So the metastore is really that parent object that helps register all of your catalogs, schemas, and tables. It all rolls up to a metastore, and the goal of the metastore really is to interact with your cloud environment. So you have to configure your cloud infrastructure to be accessible to that Unity Catalog metastore. What that really means, depending on which cloud provider you're on, for Amazon, we had to deploy a metastore IAM role that was registered to that metastore and essentially had cloud storage access to all of the buckets where our Lakehouse data lives. And once you do all of that kind of setup, the last thing you need to do is set up a Spark environment. And so your Spark environment has to be compatible with Unity Catalog, which means you need to be on a later Databricks runtime. We're using 11.3, but if you've been following along with all of the announcements that are going on at the summit, highly recommend you're on the latest runtime to take advantage of those features. And the last thing you'll need to do for your Spark environment is make sure you have a data security mode enabled. So essentially, you'll have to make sure your Spark clusters are running in what's called single user mode or shared cluster mode. The details of which is when you enable those modes, your Spark clusters will basically have your queries go through Unity Catalog. So once you get through all of that setup, you get the benefits of Unity Catalog. And all of those features that we've been talking about, I want to highlight, it's a free metastore service offered by Databricks, which is huge for everything that you're getting. The one thing I will say about the Unity Catalog architecture, which will start leading into all the impact you can get from it, is it's better to understand the architecture from the life cycle of a query. So with Unity Catalog enabled, users still attach to a Spark cluster and submit their queries to that Spark cluster to get results. The thing that happens is essentially those queries and the plans of those queries are evaluated by Unity Catalog, and that allows it to understand what are the underlying data sources it needs to resolve the query. What it then does is it verifies, one, that those data sources are accessible to that user, and if it is, it's going to go locate across your cloud storage where those data objects and sources live. And if you're working with just raw files with Unity Catalog, that works too. Those permissions will still be validated with Unity, and it will just kind of access those storage locations in your cloud environment. The key thing here is it's not going to actually do the fetching of the data access for you. It's a subtle detail, but it actually generates pre-signed URLs, basically authenticates those links, and sends it back to the Spark cluster so that the Spark cluster actually goes, retrieves those data objects, so basically those S3 objects, using the links provided by Unity, and then it goes and resolves the query. So the Spark cluster is doing the data fetching and retrieval. Unity is mostly just kind of identifying and authenticating into your cloud. And that separation between user permissions and the compute environment from Unity interacting with your cloud gives you a lot of capabilities to really optimize your Lakehouse. And we're going to start talking about that. And so, the main thing I want to get across as we go through this Unity Catalog impact is it's not really a governance tool. It actually gives you a lot more foundation and efficiency within your Lakehouse. But the first thing I want to revisit is all the problems that we had with our Lakehouse growing so quickly. So we talked about how data access was really complex. But with Unity Catalog, it's the opposite. Data access is really simple, and it's universal. So to kind of tell you a little bit of what we did once we enabled Unity Catalog, we kind of took a ground-up approach and reorganized all of our data assets. So the first thing we did is we took our source data sets and made sure that we registered them in Unity Catalog as external locations. That basically tells Unity Catalog that here are some storage locations. There's data there. If someone wants to query it, it can access it through Unity. The other thing we did is we brought in our full 210,000 tables back into Unity Catalog. And the big difference here is when we introduced it back, we took the opportunity to kind of rethink the catalogs and the organization of those tables there. So we try to make these catalogs now represent our business units so that those tables are a little bit more well-defined and scoped. And so because we did this whole reintroduction of these tables and these storage locations, we could start processing all of our bronze tables and our ingestion through Unity Catalog. And during our migration, this was basically the first thing that we did. And as we were creating catalogs, we basically kind of kept mirroring different business units through those catalogs. And the cool thing about it is it's not really, it's kind of a metadata object, so you can create catalogs very quickly through Unity. There's nothing special about it. And so you can get really aggressive about the number of catalogs you have, and the more that you have, I think you do a better job with data organization. So once we brought back the tables, then we started to introduce our users back to our Lakehouse. And so the key thing here is before, we kind of treated teams as these atomic units that kind of worked in isolation. They have their own cluster, their team instance profile, their IAM roles, their set of buckets that they can use. But we didn't want to reintroduce that problem because that certainly didn't scale for our organization. So the thing here is we now have our teams more fluidly interacting between our different catalogs. And it's kind of a subtle difference, but the thing is we want to organize our teams around the data rather than the other way around, because these teams are fluid. They evolve over time. Their responsibilities change. There might be new members being added or removed at any given time. So we want our data to be more of the focal points within our Lakehouse and have our users be more fluid around it. And so to do that, we basically use those ACLs in Unity Catalog to say that different teams can have read or read-write access to different data objects and different catalogs. And so basically, we would typically give each team a subset of databases or schemas, read and read-write access. And one of the things that this finally kind of unblocked for us is for more restrictive delivery requirements for teams that focus with our corporate or data partner clients, we could create isolated catalogs and environments for those teams and allow them to kind of work securely with those customers, and that really helped unblock them. And so they're much more efficient at now resolving and addressing the needs for those client personas. And so it goes to show that you can be very collaborative, but also very restricted in your environments. You get the full spectrum of access control with Unity. The last thing I'll mention is on the data access side is that it really simplified our cloud infrastructure. So over 70% of our cloud infrastructure before, we were managing it all at the cloud infrastructure layer to do all of our data permissions. All of that kind of went out the door with Unity, and that was a great thing because Unity Catalog connects to your clouds through a single metastore role. So you can have as little as basically one IAM role to govern your entire data access to your Lakehouse, which is great for our data infrastructure engineers. And so really what happens is no matter what team is using Databricks and attaching to whatever cluster they want, their user permissions follow them because that's all registered within Unity. And Unity will just assume basically that metastore role and then access the cloud and only retrieve the data that the user has access to. And so because that access is kind of centralized through Unity Catalog, a lot of the permissions, the IAM roles, all of those instance profiles and team dedicated clusters are no longer necessary. The other thing is if teams wanted to work directly with the cloud SDKs, which they do sometimes in our platform, they can still do that authenticating to the cloud through Unity Catalog. And the reason we do that is we want Unity Catalog to be our central gateway for all of our data permissions. We don't want to create any side channels for them to authenticate to the cloud. And there's a really cool temporary credentials API endpoint for Unity Catalog that allows you to basically generate temporary credentials and create this cloud SDK to work with the cloud even without a Spark environment, which has been very useful to us. So altogether, that's really simplified our cloud infrastructure. With data access kind of being a lot more manageable, I wanted to dive into the next thing that Unity Catalog has solved for us, which is driving collaboration between teams. And so the first thing that we've noticed with Unity Catalog that really stood out is the Data Explorer. And so with the Data Explorer, there's a ton of really cool views. I wish I could show it to you all, but the main thing is you can search for your data objects in Unity Catalog, and you can see for a given data object all of the information. So for example, this is one of our tables in our Lakehouse, and you can see field level information, table size, all of this kind of important metadata for any of the data that you have access to. You don't have to ask or shoulder tap anyone else to know what tables you can use. What we have been pushing teams to do is actually commenting or documenting those tables in Unity. So you can essentially say within Unity Catalog, descriptions for your tables and also field level descriptions. And you can annotate that all directly in the Data Explorer, but you can use Spark too. And what we've noticed is these documented tables are more likely to be used because other teams can quickly understand the context of those tables, how to use them without ever having to have like a synchronous kind of collaboration. And so we're seeing more asynchronous collaboration, which is great. It's a lot more productive for an organization because you just quickly know what tables you can use and how to use them. If you need a link to internal documentation, you can do that too. It does support Markdown, so you can get pretty fancy with those comments. And the last thing I'll mention is that the History tab that's in the Data Explorer is another way to give a lot of transparency to teams. So since we use Delta tables, in the History tab, you can see for every table that you have access to, the entire Delta transaction log. You can understand when tables are updating, who is updating those tables, how those tables are evolving. And so that just gives a lot of visibility to the teams that are consuming tables from another team. The other thing that's really happened on the collaboration side is it's reduced the time to release changes to different pipelines. And the big thing here is it's the data lineage from Unity Catalog that's enabling this. So you can see in Unity Catalog for every table, the data lineage for it, so upstream and downstream relationships. It's really quite powerful. It just kind of works out of the box. But you can also see field level relationships too. So you can see how one column is derived from another column. And this is really being used by teams to make sure that they prevent bad releases of data pipelines, because now if they know they're going to change a pipeline or change a table, they can see which fields are going to be impacted and if that's going to impact another team. And so we can see like all of this analysis can be done very visually without much effort by these teams. The other thing I'll mention about the lineage that's pretty cool is it integrates with Databricks workflows. So you can see how lineage is actually mapping to the ETL pipelines that you're constructing. So a lot of quality of life improvements that come with Unity for these teams managing pipelines. And even if you're not using the Databricks UI, you can actually use the lineage data via the REST API. So if you want to build systems outside of Unity Catalog to look and analyze this lineage information, you can do that, and it's pretty powerful. So collaboration's gotten better, data access has gotten better. The next thing that we've noticed is we can actually optimize our Lakehouse operating costs using Unity. And the thing that we're doing here is we're actually analyzing our lineage data at scale and pruning tables that aren't being used. And so our problem before of understanding what in cloud storage is being active or not is now correctly and very accurately addressed. And we've seen using lineage data that over 27% of our cloud storage was actually inactive. And we did this by using the lineage data and the audit log. So with the audit logs, you basically get an event stream in Databricks for every single table that's being queried. It's a very simple group by operation to see what tables are being queried and how often. And with that kind of data set, you can see what tables have never been queried. And what we did is we actually joined it to our cloud inventory reports to see the overall kind of percentage of our lake that was completely inactive. And so now we can be very surgical and very confident that we can delete unused data in our lakehouse and make sure we're not paying for unused storage. The other thing we did is for the tables that are actively being used, we actually use the column level lineage to see if there's any improvements there that we can make. So with large tables, tend to have a lot of rows, but if certain columns are not being used, and we can tell that now using the Unity Catalog information, we can actually drop those columns and really shrink the table size they're in, and that can really be very effective in improving performance. And if columns are being used, something cool that we started to do is we look at essentially the ordering of the columns. With Delta tables particularly, the first 32 columns of a Delta table you collect statistics on. So for the columns that are being frequently accessed, we want to make sure it's in the right order. That also helps with kind of query performance for downstream users. Cloud storage aside, the other area where we've kind of seen improvements in our costs for our Lakehouse is our SQL Warehouse Bill. So the important thing with Unity Catalog is the user permissions follow you regardless of what cluster you're attaching to. And that gives us the opportunity to really consolidate the number of clusters and warehouses that we're using. And so in the past, before Unity, we had SQL warehouses for each team, and that led to a lot of inefficient spend. And so each team may not be always utilizing those clusters, and that led to a lot of kind of unused compute that we were spending on. But with Unity, what we've basically done is rapidly consolidate the number of SQL warehouses because they can be concurrently used across multiple teams, and those user permissions will still be respected. And so that really shrinked our compute bill because we had fewer warehouses to use. But additionally, we noticed that the query performance of those warehouses was actually better. So we use Databricks autoscaling for these warehouses, and we've seen that as more teams are kind of sharing a cluster, those autoscaling events actually happen more efficiently, and you're getting better optimal spend on your compute because those autoscaling events are less spiky and more predictable. So with all those cost improvements, we've also improved our Lakehouse for our business by opening up new product opportunities. So the first thing that we kind of discussed at the beginning of the presentation was that Amazon Live dashboard. But to build this kind of data experience, we noticed we had a lot of challenges with Hive Metastore. And that's because to build BI experiences like this, you have to have very fast metadata operations for your queries. And we noticed with Databricks SQL, which is powering experiences like this, that some of those metadata queries, for example, you'll see in your SQL warehouse, it'll randomly run show tables or show columns in tables. That just happens automatically, and there should be nothing wrong with that. But with Hive Metastore, for when we're working with over hundreds of thousands of tables, it simply can't do these metadata operations. And we noticed that these would crash our SQL Warehouse because scanning that metadata just takes too long for Hive. But with Unity Catalog, it's a completely different architecture, and as we've running these same metadata operations, we've had no issues. And that was key to unblocking building experiences like this. So actually, some of these dashboards were some of the first users of Unity Catalog we had internally. And ultimately, this is really opening up new client experiences. This is becoming one of our most popular kind of data experiences for our clients. The other kind of new product opportunity that we're really excited about is now we can use the Databricks Marketplace. I'm sure you all have been hearing about it at the summit. Just last week, we pushed our first data set to the Marketplace, which is our email receipt panel. This is a really popular data set that we offer to a lot of our different clients. And it's a really powerful data set. But before, we had to do a lot of complex delivery infrastructure to distribute this data to different clouds, cloud environments where our clients live in. But with the Marketplace, we can now take these gold tables that are in our Lakehouse and package them as Delta shares. And for clients who want to use this data set, it's just a read-only catalog for them. So it's quickly integrated into their own Lakehouse environment. The other benefit is being on the Marketplace. It allows for fast discovery, so we can get in touch with new prospects that we not have known about in the past, and they can quickly activate and determine the value of these data sets without much hassle. And for us as a data provider, these tables are shared with no extra infrastructure or compute processing on our side, which is really, really important for our type of business. And that's all through the open source Delta sharing protocol. So with Unity Catalog, you get Delta sharing kind of built in. It just has a Delta sharing server out of the box, so if you're ready to externalize your data, you can do that. So with all of those kind of benefits and impact that we've created internally, I did want to shift focus and talk a little bit about how we migrated from Hive to Unity. And the biggest challenge for us was that we have 2,000 pipelines running every day. We have daily SLAs, multiple teams kind of relying on these pipelines to run without any friction. So we had to somehow do an in-place switch to Unity Catalog from Hive with basically zero downtime for any given team. And so this really required us to be a little bit more strategic and thoughtful about how we cut over to Unity Catalog. And we basically kind of looked at how teams are managing our tables internally and figured out a way to kind of do this switch. So for context, our teams use Spark to create tables and do their ETL. But the cool thing is they use a standard library that we provision internally. So every team is using this library to manage their ETL pipelines. And so we have a standard function for them to create tables. We call it create table internally. Here's a kind of a quick code snippet of it. Really doesn't do much. I mean, internally it actually does a lot more, but for the purpose of this kind of just demo, this is really all you need to understand about it. It takes a database name, table name, and a data frame, and goes and overwrites that Delta table. What we realized is we could use this as a way to kind of inject Unity Catalog functionality behind the scenes without really having teams to modify their code. And so the first phase of our migration was really about having teams continually working with Hive Metastore, but passively syncing that table metadata back to Unity Catalog and kind of building up that catalog incrementally. And so we made some adjustments to our create table function where all of a sudden, with Unity Catalog enabled, we continually and kind of force people to still write to Hive Metastore. And you can do that because the cool thing with Unity is once you turn it on, you can actually still write to Hive Metastore. It just appears as an additional catalog in your environment. But then we use what's a really cool operation that Databricks provides, the sync operation, which basically allows you to sync from a Hive table all the metadata into a particular Unity catalog. And so we could just copy that table metadata over. They're still external tables. We're not copying data over. It's just pointing to the same underlying kind of information in our cloud storage. And so as that was going, as multiple teams were kind of running their pipelines, we kind of gradually were building up Unity Catalog and having references to all of the tables they manage. And at some point, once Unity Catalog was up to parity with Hive, we basically cut teams over to write directly to Unity Catalog and then sync tables in Hive as a background. So our create table function looked a little bit like this, where all of a sudden, we'd now start writing directly to a particular Unity catalog, and we take that Delta table location and basically overwrite the Hive table. It's a very simple example of what we kind of did, but the key thing here is at any given time, all of anyone's tables within our Lakehouse was accessible in Unity and Hive for the purpose of this migration. And what that really allowed us is it enabled our teams to switch to Unity Catalog with minimal code changes. And it did take a little bit of extra work, but it also goes to show you how compatible Unity is with Spark out of the box and existing workflows, because it's really just about copying metadata over. And we had a lot of confidence in doing this because pipelines could fall back to Hive Metastore if we ran into kind of permission issues or any kind of hiccups during this migration. So team by team, we kind of moved them to phase 1, phase 2, and eventually all of their teams were on kind of that phase 2 of that migration, and that's where we stopped kind of our essentially usage of Hive. So to kind of conclude, we talked about a bunch of different topics. We had a bunch of growing pains with Unity Catalog, or sorry, with our Lakehouse, but Unity Catalog is actually resolving it. So we talked about how data access was really complex before with Hive Metastore and the complexity of our organization, but that 3-level namespace and granting precise access to user groups in Unity Catalog is really addressing this problem. We talked about how data isolation was really tough when you're kind of managing team-based permissions at the cloud storage layer, but now with Unity Catalog, we can actually break down those walls, use the Data Explorer, build documentation into tables, and help data assets be discovered more directly across teams. And that cost overhead of that growing petabyte scale lakehouse, we have a lot of techniques now to help manage this over time. We can use Lineage data to see where in our cloud storage it's being inefficiently used or not used at all, delete that unused storage, as well as consolidate a lot of our compute. And we've now really been able to externalize our data sets for new business opportunities. We're really excited to be on the Databricks marketplace. We're going to be pushing many more data sets in there in the future. And we have new experiences that we can build through BI tools that are now really performant because of using Unity Catalog. And that's really what I want to get across. Unity Catalog is a data governance tool, and it's a great one at that, but it does a lot more. It's that foundational element in your lakehouse that once you enable it, you can really activate your lakehouse and have your teams really create a lot more value and productivity for your organization. And for us, now that we've been on Unity Catalog for a couple of months, our lakehouse is starting to look like this again, and we're really excited about that. That's thanks to Unity.